It's space weather, or more like a lack thereof. 0 sunspots for several days. There is a coronal hole. It's not very highly defined, and it's pretty much facing right at the Earth. Looks like a little bit of missing data there. Not sure why we're getting that sudden faster rotation. The sun is not rotating faster. I can guarantee you that. Take a look at the 304 angstroms view. I know there is a little bit of filamentary activity going on. Take a look at that. And here are your magnetic lines. A little bit confused as to why this slightly to the south of the equator coronal hole has not yet magnetically connected to the Earth. We do not see the phi angle showing up from this yet. And it's a little odd that it's not connected yet. Let's take a moment to go to inthesky.org. Take a look at the sky map. Why? Because it's before sunrise. And while this video is uploading, I'm going to go outside and see if we can see some Orionids. If you're able to get to this video before the sun rises, Sunday, October 21st, look at this part of the sky. Right there near Orion's shoulder. Right now we're getting about 15 meteors per hour spotted in the Orionids. So take a look at that if you get the chance. Moving on to the space weather data, or lack thereof. Solar wind is extremely low. Cosmic ray flux is going to be extremely high. And we're going to cover that a little bit in a minute. Okay, now we do actually have a spike here in the solar wind density. Solar wind density is all the way up to 20.68 protons per cubic centimeter, which is double what it was just a few minutes ago. So this could be the front of the coronal hole wind stream. Not exactly sure on that. But usually we get an increase in the wind speed too, obviously. And the solar wind speed below 300 is about as low as it ever gets. Head to spaceweathernews.com. X-ray flux is still flatlined. The ACE appears to be showing a lower density than the Discover. Magnetometer is in a smooth range. Here's your story. Another full day with a KP of 0. What does that mean? Health risks associated with cosmic ray flux. Electron flux is dropping off, which is an additional shield. Keep in mind that when a solar proton hits the ionosphere, the more electrons that are there, the more deflection occurs. So the lower the electron flux gets, the higher the potential cosmic ray flux on top of all that other stuff gets. Remember, most cosmic rays are hydrogen nuclei, solar protons, and obviously the more electrons they have to interact with in the ionosphere, the more of them are going to get deflected and the less of them are going to get funneled into the planet. Take a look at solar ham real quick. You can see there's just nothing but weak mixed magnetic fields. No sunspots, a couple active regions there, but super weak. Let's talk for a quick moment about health effects from cosmic rays before we go out and try to see some Orionids. Now, remember, most cosmic rays end up at the poles, which is why it's more dangerous to fly at high or very low latitudes around the North or South poles. That is because of field-aligned currents. Field-aligned currents are going to pull those protons to one pole or the other, as opposed to allowing them to just enter the Earth. Now, some cosmic rays are electrons, some cosmic rays are neutrons, and some of them are helium nuclei also. In any case, leave the links below, read up on this, help us get to 200 subscribers. If you haven't subscribed yet, please feel free to do so. Please leave a like, leave a comment. Questions, suggestions are always welcome. Thanks for viewing. Don't accept any wooden nickels. And if you get the opportunity, before sunrise this morning, as we shall, head out and see if you can see some Orionids.